Welcome back from spring break. Um, Weird as it might be, this week we're only going to have one assignment, and that will be the one on Wednesday. And so there'll be just this one video to go with it. Um, Today, we've looked at the law of sines and the law of cosines and how to solve triangles from them. Remember that the law of sines was when you knew an angle and a side opposite it and one other side part. Law of cosines was side angle side, side side side. This was angle angle side, angle side angle, and angle side side. The ambiguous case. We won't have any of those in word problems like this. So we're looking at applications of those. Probably the hardest part about it is to go from the words to draw a picture. Once you have the picture of the triangle, it's pretty easy to solve it because it's just like all of the other problems that we've solved. So we're just going to look at some examples. So the first example, two surveyors are determining the distance to a tower located between them but across the river. So I just stop right there. They want the distance to a tower that's located between them but across a river. So if these are my two guys, the first guy, we'll call him A, and the second guy, we'll call him B. The tower's in between them, but somewhere across the river. So there's the tower. And what that does is creates our triangle then. And it says the first one determines that the line of sight to the tower makes an angle of 89 degrees with the bank of the river. Here's the bank of the river. And so his line of sight to the tower makes an angle of 89 degrees. 495 meters downstream, another surveyor, so this is 495 meters, determines that his line of sight is 55 degrees. So now we can look at how far is each surveyor to the tower. So we want to know how far A is here and B is here. We want to know those two distances. Now you look, this is a case of angle, side angle. On the surface, we don't know an angle and the side opposite it, but really we do, because if we add 89 plus 55, that's 144 degrees. Subtract that from 180, and this ends up being 36 degrees. And so we can use the law of sines to find that. We're going to use it twice. We're going to say the sine of 36 degrees over 495 is equal to the sine of 55 over B. And we're going to use it for the other angle, is we're going to say the sine of 36 degrees over 495 equals the sine of 89 degrees over A. And now it's just a matter of taking your calculator and solving it. B is going to be equal to this times this divided by that. And so if we take our calculator and we do that, we're going to go 495 times the sine of 55, and we're going to divide that by the sine of 36. And we get 689.9 meters. So B equals 689.9 meters. If we then look at over here, I'm going to go 495 times the sine of 89. And we're going to divide that by the sine of 36. And I get that A equals 842.0 meters. So those are our two answers. So again, the hard part of it is being able to draw the picture and understand what they're saying. So let's look at the second example. Determine the length of an airplane. A person walks 300.5 feet from point A, the nose of the aircraft, to point B, the end of the wing, and then turns 80 degrees and walks 250 feet to the tail of the airplane. Find the length of the airplane. So we'll just start out by here drawing kind of a like an airplane here. Very sad looking airplane. So point A is at the nose of the plane, point B is at the tip, and we'll call this point C back here at the tail of it. And so we draw our triangle in here. And now we'll try and put in the information we know. He walks 300 feet from point A to the tip of the airplane, or the wing. So that's 300 feet. And then 250 feet to the tail. It says he turns 80 degrees. So if you're walking like this, and you turn 180 degrees, you're going to turn around and go back the other direction, right? And so if I turned 10 degrees, this would be going 0 degrees if I kept going this way. 10 degrees it'd be here, 20 it'd be here, 30, and so on. So when it says 80 degrees, this angle right here is 80 degrees, not the angle inside. The easiest way to say that is if you were going this way and you turn 10 degrees to your left, you're not going to be going back here to where this angle is 10 degrees. You're going to be going this direction. And so if this is 80, this angle inside here is 100 degrees. And so now we look at our triangle and we go 300, 250, and 100 degrees. That's a case of side angle side. So that's the law of cosines. And we want to know how long the airplane is, so we'll call this length B right here. So the law of cosines just said that B squared is equal to the other two sides squared added together minus 2 times those two multiplied together times the cosine of the angle in between them, which is 100 degrees. That's something you can put right in your calculator. And so if I do that, I would go 300 squared plus 250 squared minus 2 times 300 times 250 times the cosine of 100. And that's what B squared equals. So we need to take the square root of that. And the answer that you want is down above the negative sign. And I hit enter, and I get that B equals 422.5 feet. And that's the length of the airplane. All right. So again, the key to that one is recognizing the 80 degrees is not this angle inside here. 80 degrees is how much you turned. And then this is the remaining from 180 degrees. This is a straight line. All right, third example. A kite flyer lying on the ground is looking at her kite in the sky with an angle of elevation of 71 degrees. Why she'd be laying on the ground, I don't know. Maybe she's just lazy. But if there's 1,500 feet of kite string and it is taut, what is the height of the kite? So kite flyer's laying out here. Here's the ground. The kite's up here, flying up here in the air. And here's the kite string. And we know that there are 1,500 feet of string out. And it's taut, meaning it's tight. We want to know how tall or how high off the ground is the kite. The angle of elevation is the angle that you have to look up from the ground. So this is 71 degrees. Now you could use the law of sines here, but this is just easier. It's a right triangle, so we're going to use SOHCAHTOA. To this angle, this is opposite. Hypotenuse, that's sine. So I can just say the sine of 71 degrees is h over 1,500, or 1,500 times the sine of 71 equals h. And again, then you take your handy little calculator and you go 1500 times the sine of 71. And you get 1418.3. And that would be feet. And that would be your answer. If you did the law of sines, we could do, since we know an angle and the side opposite it, I could say the sine of 90 over 1500 equals the sine of 71 over h. And when you solve that out, this times this divided by this, the sine of 90, if you remember from your unit circle, sine of 90 is 1. So it ends up being the same thing. All right, the last example, 2 points M and N are separated by a swamp. A baseline MK is established on one side of the swamp. So we have this little swamp down here. And we got M and K is on one side of the swamp. Right? So M and K. A baseline, let's see, MK is 100 meters in length. 180 meters. N is on the other side of the swamp. It says M and N are separated by a swamp. So there creates our triangle. The measure of angle K is 62 degrees. And angle N is 74 degrees. Find the distance between M and N. So that's what we're trying to find. So I know an angle and the side opposite it. That's the law of sines. So I can just say the sine of 74 over 180 is the sine of 62 over x. Solving that for x, I know that I'm going to go 180 times the sine of 62, 180 times the sine of 62, and then I'm going to divide that by the sine of 74, divided by sine of 74. And I get that x equals 165.3 meters. So that's the type of problems you're going to be working on. Again, take your time. Try to read it carefully. Don't try to read this through really fast. Take it one line at a time and try to comprehend and draw a picture from that. Make sure you send me your questions if you have any.